Hello everyone, my name is Sait Cakmak and I will be presenting Bayesian optimization of risk measures. This is a joint work with Rahul, Austdillo, Frazier, and Enlu, Zhou. Let's go back to the beginning of the summer when my colleagues at Cornell University were tasked with designing a COVID-19 testing strategy for bringing students back to campus for the fall semester. They had a simulation model that, given a testing strategy X and a set of environmental variables W, would predict the disease spread within the campus community. And their goal was to design a testing strategy that was risk-averse to these unknown environmental variables. Inspired by this and similar other problems, in this work we focus on risk-averse optimization of the form, minimizing with respect to x, a risk measure rho of fxw, where w is the random environmental variable with known distribution, f is a continuous black box expensive to evaluate function, and rho is a risk measure, which is a functional that maps a random variable to a real number, and it offers a middle ground between the expectation and the worst cases. In this work, we studied two important risk measures, the value at risk and the conditional value at risk. Optimizing a risk measure is well understood when f is an inexpensive function with a convenient analytical structure. However, when f is expensive to evaluate, derivative-free, or is a black box, we do not have many options, and I have to refer you to our paper for more details on this. In this work, we propose a new knowledge gradient type acquisition function, the PKG Acquisition Function, which builds on the Gaussian process model on the function f and the implied posterior on the objective, and it selects x and w to evaluate jointly. At the bottom, we see value of information plots corresponding to the PKG Acquisition Function on the left and its cheaper approximation on the right. What we see here is that for any given x, these acquisition functions really care what w we evaluate from, and that the value of information varies widely on the w-axis. Here we have some results where we compare our approach with the standard benchmarks from the Bayesian optimization literature. In the gray, we have the PKG Acquisition Function. In the pink, we have its cheaper approximation. And in brown, we have the random sampling that is operating under our statistical model. The random sampling is telling us that there is a lot to gain from just using our statistical model, which captures all the information available on the evaluations of the function f. We also see that our acquisition functions are able to achieve the same level of performance or do even better than all the benchmarks using less than half as many function evaluations. Thank you all for listening, and please see our paper for more details.